So hi guys, welcome back to my YouTube channel. Today we're gonna discuss how to design a 5 node home automation module. So the requirement is you should be able to control 5 loads, any of the loads like lights or fan, maybe some fancy lights or something like that. So you should be able to control using an IoT platform where you need a microcontroller which has capability of Bluetooth and Wi-Fi, and you need some connector where you can connect the switches which by which you will be able to control the relays or the loads indirectly the loads manually when the internet is not there. So in order to power up the microcontroller, you will need like power circuit also, and some of the safety precautions also. Some safety precautions we should take up. So let's not waste much time and directly go to the designing part. I'll be designing the circuit and the schematic in RTM circuit maker. I've already designed it, just like turning it open. I'm gonna explain in detail. Let's see how we are. So here is ESP32 room 32E model, which is very generic ESP from the ESP Expressive family. So which is capable of Bluetooth and Bluetooth and Wi-Fi. And let's see how to we are using this ESP32 module, right? We have to power up the ESP32 module, so we need a power circuit. So let's focus on the power circuit first, and let's later go into the other components. So starting with the power circuit, we have 230 volt, or wherever, which with respect to which country you have the phase power supply, and you should be you need to convert into 5 volt. You need to convert into 5 volt. So you for that we'll be using an Highland PM01 module. Let me check that PM01. Okay, PM0 Highland module. PM0 High-link module, which is of 3 watt. That's more than sufficient as far as a file like we consider. That's more than sufficient. Like 3 watt module is sufficient. So that's why we are considering PM01, and which converts a 230 volt into 5 volt DC, to the AC into 5 volt DC. So let's before giving power supply into this converter module, we need to use a safety device where we'll be connecting a 5 amps fuse. Here we are using a 5 amps fuse box. 5 amps fuse box. Since we will be using a 5 amps fuse box, in case where the fuse blows up, you can change the fuse, right? That's why using a 5 amps fuse box instead of directly connecting the fuse into our PCB board. So let's further go down the line. We have 5 volt here, and you are using a switch in order to turn and off the entire circuit. And in order to power up the ESP32 module, we can't power up with 5 volt, right? So we need a regulator. We are using a LDO, low dropout regulator, which gives out 3.3 volt from 5 volt. Let's see some of the specifications regarding with respect to this module with LDO. Let's open let's see. Uh, oh, let me come back. Control C, and let me come back, and let me search this. Okay, we got the LDO. So here you can see the specs. So the maximum input voltage is of 15 volt, and we need up to 3.3. We need 3.3 output, and we it can deliver up to 800 milliamps, which is more than sufficient. If you have more relays and all, should be I mean not relays exactly. Mostly 800 milliamps is more than sufficient for most of the microcontroller applications. And if there is any particular application where you need more current, you will have to select a better LDO. So here this is very common series, LDO LD 1117, which is very common series. In order to I'll show you how to select the LDO. Let's go to the categories: voltage regulator, low dropout regulator category. So you'll get a number of LDOs over here. So there are different LDOs with different output. So you can here in the digi key you can give select what is the voltage output you need. Let's say up to we need 3.3 output maximum output. So just give apply, you'll get all 3.3 voltage LDO. You will get all 3.3 voltage LDO. So based on the requirement, you will have a lot of specifications into with respect to that. So you can select a suitable LDO and go with it further with the design. So let's I in once as we have connected the LDO, uh, we need decoupling capacitor, which is very common with the LDO design. We are using zero point 0.1 microfarad and 1 microfarad and 10 microfarad at the both the side inside input and output side. So the lowest micro capacitor, which is basically used to filter very high frequency noises. So it should be very close to the terminal pins. And down the line if you check, uh, down the line if you check, I've given a resistor which is connected to a red color LED into 3 by 3 line. So in order that is to indicate just the power supply. Whenever the power supply is there, the red LED will turn up. So we have done with the power supply circuit. There's no much big complicated stuff in the power supply. Most of the things are handled by the PM01 module, and we need just a LDO in order to power 3.3 volt. And let's go into the relay part. In order to control the relay, I mean higher voltage like 230 volt, we need a relay, right? So let's focus on the relay. Our design was with respect to controlling a load maximum up to 5 amps. So here we are selecting a very small size relay which is capable up to handle up to 5 amps, which is um, HFS1T, which comes under HF46F. So with this form factor, it is very minimalistic size you will be able to achieve. So that's why it can handle up to 5 amps. Okay, so this is very suitable because the size is minimal in order to place inside our electrical circuit. So we are using very minimum size relay. So yeah, and let me explain you this part, the relay part. So relay, as you know, the relay has a coil, right? One of the terminals directly given into 5 volt, and other terminal is connected as into output 1. I'll show you where this output 1 goes up. Before that, I've connected a flyback diode. Most of you might know the application of flyback diode. That is because during the operation of turning off the relay, when the relay is turning off, at this point you will have a very high spike, which actually is a problem because during the high voltage spike, it is directly connected to one of the IC which we have, that is ULN2003 LVDR, which I'll be going into that. So at this pin you will have a very voltage high spike, which is not preferable for the IC, right? So that's why passing bypassing those high voltage into our voltage source. So that's why most of the relay circuits will find relays, I mean the flyback diode. And here we have the output one, that is terminals connected to this IC, that is ULN2003. This is an like let me show you the data sheet of this. That would be better, I guess. So here you will have so yeah, this is ULN 7 channel relay and inductive load sinking driver. So the main application, I'll show you the inside at each pin what is the circuit available. You'll have a better idea of, and you'll understand it better. So when the input is high, that is like when you want to turn off the relay, you will give a high input, right? So high by front microcontroller. So that will control this MOSFET, which is the NMOS, and it will start conducting. As soon as it start conducting, the output will be directly pulled to ground. So the output one, where the output one terminal is connected to ground. So that's how, like whenever you have 5 volt at one terminal and ground at one terminal, the relay will be on, and the relay will will close up. So that's how the phase will pass on to the phase will pass on to the load, and your load will be on. Your load will be on. Let me go back to the data sheet. Here you can see the different input state. When the input is low, the output is high impedance state. When the output is low, high is the output is directly pulled low. So yeah, let's go back to the design. I hope you have understood what like how the relay is connected and how we are using this ULN203 LVDR module. It's a relay control module which is very commonly used in for this application. So here we have connected a common rail, that is 5 volt, and where we have put a 1 microfarad decoupling capacitor. So, and here we need 4 mounting holes to design the PCB. So we have 4 mounting holes, and which is M3 size screws. We'll be using M3 size screws for the like hardware, the hardware box which the mechanical team will be designing. So here we have load connector, which is a screw terminal similar to what we have used at the starting in order to connect phase and neutral. So the loads will be have a higher a higher current wiring. So you'll be have a higher gauge wire. So you need screw terminal connectors where you can connect the wires from the load, which will be connected to these points L1, L2, L3, L4. And let's go come back to, yeah, regarding the programming points, I will let you know. I'll cover up that part soon. So before that, let's see what are the switch connector. So you'll have a switch, right? So you will have a switch which is in order to control the switch manually, which is a normal switch which is there in our home uh, switch boards. So using those switches, we should be able to connect into our microcontroller. So we are using a pull-up resistor. Let me just drop that. Let me take a paint. Maybe, yeah, once again I'll draw it up. So here we have a pull-up resistor connected to. Here we have 3.3 volt, and here we have the IO, the terminal IO, and here we have the switch. Here we have the switch which is connected to ground. As soon as you press the switch, the IO terminal will be will be pulled low, and if you remove the switch, if you turn off the switch, yeah, it'll be pulled up by this resistor, which is of 10 kilo ohm. That is how that application is. So this switch can be connected to this switch can be connected to our this GST connector, which is it carries very limited current, right? Because it is just connecting to ground. It is just pulling low the line, so it is very low connector. So directly you can connect with very less gauge wire. So using a GST connector, you can connect. So here is the array of pull-up for each of the switches. And let's come back to our microcontroller. I guess most of the part is done. So let's come back to our microcontroller. So here you will get the data sheet for different the each of the microcontroller, right? So ESP32 from 32E module, which is has a PCB antenna, and 32UE module, which is which has got a connector where you can connect an external antenna. And yeah, let's go to one of the circuit which I'll be showing you. That is not the peripheral application, so physical, yeah, peripheral schematic. So this is one of the most important diagram in this data sheet. Let me close this up. Let me zoom. So yeah, this is shows the pinout diagram of each of the what pinout diagram for this module, where you have to connect the oscillator. You don't need to connect an external oscillator because there's no very time specific application to a very time critical application is not there. So internal oscillator will be more than sufficient for this purpose. So here mainly what we have to see is we have to see the 3v3 rail where we'll be connecting the 3.3, and some of the decoupling capacitors are already suggested by the manufacturer of ESP32 ESP from the expressive. So you have to use an 22 microfarad and zero point 0.1 microfarad decoupling capacitor. And for the enable pin, you'll be connecting resistor. I have used a 10 kilo ohm resistor and zero point 0.1 microfarad 100 nanofarad capacitor. So this is in order to only this why we are connecting this capacitor is because first initial state it will be dully short circuit, right? So initially it will be reset, the enable will be pulled low, and slowly once the voltage rail is stable enough, only then the ESP32 will be on. So once I say a voltage rail is stable enough, only then the voltage the ESP32 will turn on. So that is why you need a capacitor in order to slow down the process. Or as soon as if it is directly connected, when the voltage rail is not stable, if the there will be a fluctuation of enable pin, right? So that's why we are using this capacitor. And let's come back to other things. These are not pins are not connected. You can connect your loads like the switches or the input to the ULN2003, and some of the switch connections that can be IO connections can be given applied into this. It depends on. I have given some of the application some connections here. I mean, no need UART, and this resistor also is not required. But regarding the boot option, it actually should be during the programming we should be grounding this connection, right? But what we have done is we have connected an contact pads, because if you are developing this as a product, you won't be asking the customers to program it. Only during the manufacturing process you need to program using you need to program, right? That's why you are using a contact. Once we go to the 3D model, we'll understand what is contact pad. So this is the contact pads where you need enable pin, boot pin, TXRX for the uploading the code, and the ground. So I guess we have done almost with the schematic, and let's directly go into our final PCB design. So yeah, I have placed most of the components already here because this is very time-consuming process. So let me show you. I have placed all the relay modules here, relays here, relay in the top part, and you can see this converter U2, that is a 232 to 5 volt converter also is placed here, and this is the here is the fuse box, and the output from the output from 5 volt is given to the switch, where you are getting the 5 volt trail, which is connected to the each pins of the relays, and the common for the ULN2003. And here in the back side, in the bottom line, let me take a single node. Okay. Yeah, this is in the bottom line. If you can see this, that was the top line, and here in the bottom line you have actually the you have the LDO and the decoupling capacitors connected. So I've created a common ground. Most of the grounds are let me take yeah. All the grounds are connected to a common ground plane, and here we have 5 volt rail, which you are connecting the 5 volt input, and here the from output from the LDO is also connected to the LDO is also connected to the decoupling capacitors. So here we have a one using the wire. I'm pulling up the 3v3 voltage rail, and connecting to the we are connecting to the pull up, as well as connecting the pull up, as well as connecting to the 3v3 rail of the 3v3 pin of the ESP32. So, and the all those decoupling to 22 microfarad and other capacitors connected here, and all this let me say Let me take a 3D view. That would be a really better switch to 3D. So yeah, let me go back to the flip. I will first cover up the backspace. So here we have ULN 203 connection, and this I mean this path is of 10 mil. This track is of 10 mil. So that would be more than sufficient because it's very low, right? Just turning on the NMOS in this ULN 203. And this output from output from this ULN is connected to the relays, individual relays, where you can see I've also connected the individual relays. I've also connected the flyback drive which I was talking about in the earlier. So I've connected the top part. I mean the diode, and here you can see I've given a high thickness track for higher amps current, and in order to pass higher amps it is of 2.5 mm 2.5 mm thickness track. And here we can see from the phase connector it is going to the from the phase point from the phase terminal it is going to the fuse box, as well as the a common rail to the relays common rail, and individual load are connected to the another terminal of the relay. And let's see, okay, apart from that we have this switch GST connected, where connecting SW1, switch 1, switch 2, switch 3, and switch 5, and the last terminal to the ground, and so yeah, and that part is. Let's flip the board and let's see the upper part. And here we have the switch which I was talking about earlier in order to turn on and off the board, and the red LED to indicate the power. And so here we have the reset button switch. Yeah, so whenever if there's any problem to so if the customer need to reset, so they can just give a reset, press the reset button. So this is the copper pads which I was talking about. So you might have heard about poker pins, right? And I'll show you what is poker pin. You might have heard of poker pins. This is like a small spring-sized pins. So where you can connect the pins to any of the programming board. So using those pins, we can connect directly into this copper pad. So where you can connect the programming circuits, and you can if it's the mass manufacturing or in like a startup stage or anything, you can easily connect the copper. I mean, use a power pin, so you can connect to these terminals and easily program and test, or maybe debug what is the issue in that. So instead of having a separate programming circuit in this module, it's of really waste because the customer is not gonna program it. So you can easily use this copper pads easily, and you can program the circuit. So I guess that is a major. And here make sure you should have a slit at this part in order to avoid any RF interference, because you shouldn't have any blockage of RF signals where which this is the PCB area of the let me clarify that. But here this is the PCB area of the ESP32 module, and you need a separation between the AC voltages and DC. I have created a slight slit of PCB cutout at this part in PCB part in order to separate the AC and DC levels, yeah, and the AC voltage. So there's a clear separation, so there is no proper problem of interference or any other part. So and here I've created a ground plane, top and bottom. At the top, yeah, at the top and bottom. So yeah, and I've put a name as 5 node home automation module in the still screen. So you can put your company logo or anything if you're manufacturing and doing this product. So it looks very neat and precise module in order to control five nodes at any of the home. any of the home. So that comes to an end to our session on home automation module designing. So in further, like there'll be much interesting videos coming upcoming in further videos. So I'll stay connected, and if you have any, I'll be sharing all the details, all the documents in the description. So stay connected, and let's see in the further videos. So do share, subscribe, and like my videos, and do comment if you have any doubts. So let's see you back. So see you signing off, Anshad.